Hello everyone. In this video, we will discuss the 20 most important questions that can be asked in the KVS, NVS, PGT Geography interview. So, today's topic is map projection. So, let's get started with the question number one. What is map projection and why is it necessary when we already have a globe? So, a map projection is the systematic transfer of graticules, of parallels and meridians from the curved surface of the earth onto a plane surface. A globe is the most accurate model of the earth, but it is expensive, difficult to carry, and cannot show detailed information for small areas. Therefore, map projections are essential for preparing practical maps. For example, road maps, district maps, and weather maps are prepared using map projections. Question number 2. Why is it impossible to represent the Earth's surface on a flat map without any distortion? So the Earth is a geoid or nearly spherical, whereas a map is flat. During the transformation of the curved graticule onto a plane surface, distortion becomes unavoidable. No single projection can preserve area, shape, distance, and direction simultaneously. For example, Greenland appears much larger than its actual size on the Mercator projection. Next question, question number 3. Which four global properties can be preserved simultaneously in a single map projection? Explain why. So the four global properties are area, shape, distance, and direction. Since a curved surface is projected onto a flat surface, preserving one property increases distortion in the others. Hence, every projection is designed according to its specific purpose. For example, equal area projection preserves area but distorts shape. Next question, what is graticule and why is the graticule the foundation is the graticule the foundation of every map projection? So the network formed by parallels of latitudes and meridians of longitudes is called the graticules. Every map projection begins by transferring these graticules from the globe onto a plane surface, after which geographical features are plotted. For example, the Old World map first construct the latitude-longitude network before drawing continents. Next question, question number 5. Explain the difference between a developable surface and non-developable surface with suitable examples. So, a developable surface can be opened into a flat sheet without stretching or tearing, such as a cylinder, cone, or plane. A globe is a non-developable surface because it cannot be flattened without distortion. For example, cylindrical, conical, and zenithal projections use developable surfaces. Next question, why are cylindrical, conical and zenithal projections called developable projections? So, these projections are constructed by projecting Earth's graticule onto a cylinder, cone or plane, all of which can be unfolded into a flat surface. Therefore, they are called developable projections. For example, Mercator projection is cylindrical while simple conical projection is conical. Next question, how does the position of the developable surface that is normal, transverse and oblique influence the pattern of distortion? So the position of the cylinder, cone or plane determines where the scale remains true and where distortion increases. In the normal aspect, contact occurs at the equator or a standard parallel. In the transverse aspect, at a meridian, and in the oblique aspect, at an inclined line. For example, a normal cylindrical projection touches the globe along the equator. Next question, explain the concept of standard parallel and why is the scale true only along the standard parallel. So the standard parallel is the parallel where the cone or cylinder touches the globe. Along this line, the projection surface and the globe coincide, so the scale remains true. Distortion gradually increases away from the standard parallel. For example, in a simple conical projection with one standard parallel, only that parallel has true scale. Next question, question number 9. Why is the conical projection considered most suitable for middle latitude region? Give geographical examples. So the conical projection provides minimum distortion in the middle latitude because the cone touches the globe along a standard parallel in that zone. It preserves shape and scale reasonably well over east-west extending regions. For example, Canada, Europe, Russia and US are most commonly represented using conical projections. Next question, why is a cylindrical equal area projection called an equal area projection? What is sacrificed to preserve area? So, in this projection, the area of every region is represented correctly throughout the map. To maintain equal area, the shapes of the continents becomes increasingly distorted towards higher latitudes. Therefore, it is equal area but non-orthomorphic. For example, it is widely used for thematic maps such as world population density, agricultural distribution, and land use maps. Next question, differentiate between equal area projection, orthomorphic or conformal projection, equidistant projection and true bearing or azimuthal projection with suitable applications. So equal area projection preserves the correct area but distorts shape. Orthomorphic or conformal projection preserves shape but distorts area. Equidistant projection preserves correct distances along selected lines, while the true bearing or azimuthal projection preserves correct directions from a central point. For example, equal area used for population maps, Mercator or conformal for navigation purposes, equidistance for air distance maps, and mnemonic or azimuthal great circle route planning. Next question, question number 12. So question number 12, why is the Mercator projection widely used for marine navigation although it produces great distortion near the poles? So Mercator projection is an orthomorphic projection in which meridians and parallels intersect at right angles, preserving local shape and direction. Its greatest advantage is that a Rhumb line or constant bearing appears as a straight line, making navigation easier. Distortion increases rapidly towards the poles. For example, ocean navigators use Mercator charts to maintain a constant compass direction. Next question, what is a Rhumb line or Loxodrome and why does it appears as a straight line in the Mercator projection? So, Rhumb line or Loxodrome is a line that cuts all meridians at the same angle and represents a constant compass bearing. In the Mercator projection, this line is represented as a straight line because the projection preserves angles. For example, ships traveling with one constant compass direction follow a Rhumb line. Next question, question number 14. Why are great circle routes considered the shortest routes on the globe but not represented as straight lines on Mercator's maps? So a great circle is the shortest distance between 2 points on a sphere. On the Mercator projection, great circle routes appear as curved lines because only Rhumb lines are straight. Therefore, navigators often convert great circle routes into a series of Rhumb lines. For example, flights between London and New York follow a great circle route. Next question. If you are asked to prepare a climatic map of India, which projection would you choose and why? So I would choose a simple conical projection with one standard parallel because India lies mainly in the middle latitudes and has a greater east-west extent. This projection provides comparatively less distortion over such regions. For example, rainfall, temperature and monsoon maps of India are commonly prepared on conical projections. Next question, question number 16. Which projection would you recommend for preparing a world population density map? Justify your answer. So the cylindrical equal area projection is the most suitable because it preserves the actual area of all regions. In thematic maps like population density, correct area is more important than correct shape. For example, comparing population density of India, Brazil and Australia requires accurate representation of area. Next question, question number 17. Which map projection is most suitable for representing India? Explain your choice based on India's latitudinal extent. So, a conical projection is most suitable because India extends approximately from 8 degree 4 minute north to 37 degree 6 minute north and lies mainly in the tropical and subtropical middle latitudes. It produces comparatively less distortion over countries with broad east-west extent. For example, most atlas maps of India use conical projection. Next question, if two countries have the same actual area but appears different in size on maps, how would you explain this using map projection concepts? So the difference is caused by projection distortion. Some projections exaggerate the size of regions located at higher latitudes while preserving other properties such as shape or direction. Therefore, equal sized countries may appear unequal on a map. For example, Greenland appears much larger than India on the Mercator projection, although India's actual area is much greater. Question number 19. Suppose you are teaching class 11 students. How would you demonstrate the concept of map projection in the classroom using simple teaching aids? So I would use globe, a paper cylinder, a paper cone and a flat sheet. By placing these developable surfaces on the globe and then opening them into flat sheets, students can clearly understand how cylindrical, conical and zenithal projections are constructed and why distortion occurs. For example, a paper cylinder wrapped around a globe demonstrates a cylindrical projection. Next question, and this is the last question for today. If you had to choose only one map projection for disaster management, aviation, navigation and thematic mapping, would you use same projections for all? Justify your answers. So my answer will be no. Different purposes require different projections because no single projection preserves area, shape, distance and direction simultaneously. The projection must be selected according to the objective of the map. For example, Mercator for marine navigation, mnemonic or azimuthal for great circle air routes, and equal area for thematic maps, and conical projection for national and regional maps. So thanks for listening. Keep listening for further audio classes. Thank you.